Hi guys, this is the second part of ciphering. In the first part, we looked at some really cool monosymbolic ciphers. We're going to see a couple of more unique ciphers in this section. The ones that we're going to be checking out are going to be the SPARTAN SKYTALE cipher, the POLYBIUS square, and the ADFGVX cipher. So those are the three we're going to really focus on in this section. Okay, the SPARTAN SKYTALE cipher was used in Roman times to smuggle messages through the enemy lines. Basically, it's really different because it uses a rod. So what you do is you take the rod and you wrap cloth or leather around it, and then you would write a secret message on that cloth, and then you would unravel it. And then you would smuggle it across, enemy lines, let's say. And no one would really know that it is a cipher because it would look just kind of like gibberish. But it could be worn as a belt or to tie things with. So it's kind of clever. Once into the proper hands, they had to have the same size rod to read the message. So how long are the messages? We can use some mathematics. If we wrap the leather around the rod 5 times, and then we will be able to write 20 letters because we will be able to write 4 across for that message. So 4 times 5 equals 20. So line 1, we have U, and then HA. And then line 2, if we take that rod and we move it, we would get VE, BRO. And then line 3 is going to be KEN, TH. And then line 4 says E, CODE. So if you put those pieces together and read it, it's going to say you have broken the code. Okay, so that's what you're going to do around the rod. Now, if I take that message off the rod, it's going to look like this. So we can't really tell what it says. Like I said, it looks like gibberish. However, unfortunately, this is very easy to break. If we look at every 5th letter, we'll have the code. So let's check it out. So the Y, 1, 2, 3, 4, 5. There's the O. So you have, do you guys see it? V and then this E, broken, B-R-O-K-E-N, the code. Okay. But once again, the really important thing about this is if you're going to use this method, you have to have the same size rod. If you don't, the cipher will be extremely hard to break if you didn't know that you had to look at every 5th letter or 4th letter or whatever. Okay, so here is what happens when the rod is of a different size. Here's our message. See how it doesn't line up and it doesn't really make sense? So the next one we're going to look at is a POLYBIUS square. I think it might be POLYBIUS. I'm not sure. So let's go with that, POLYBIUS square. It was used in Greek times in 205 to 123 BC. It was invented by an ancient Greek historian and scholar, Polybius. The original square used the Greek alphabet. Now, you have to understand that there are less letters in the Greek alphabet than there are in our alphabet, so we're going to see how we can use this. It wasn't originally used as a cipher. It was used to basically just transfer messages, but it wasn't considered a cipher. It is monoalphabetic, and you can use any alphabet with this. So whether you're in France or Germany or Japan, you can use your own alphabet to utilize this one. And there are many different variations. So the one I'm going to show you, this is just one variation of the whole entire thing. Okay, so the suggested uses of this are that the symbols could be signaled by holding up pairs of sets of torches. So when we look at the square, you'll understand what that means. It has also been used as a knock code by prisoners And this is recently, by the way. And it also has been used by prisoners of the Russian czars. In the Vietnam War, that should say the, sorry about that, guys. It was used by American prisoners. And it's way easier to learn the Morse code. So, holding up combinations of 5 different colored flags, we could represent each number. So let's check it out and see how this all works. All right, so here's an example of a standard Polybius square, and there's actually a statue of Polybius. So if we check it out, we have the numbers 1 through 5 as a column headings, and 1 through 5 as row headings. So for instance, let's say I want to say hello. I'd look at H, and then I'd read off the numbers 2, 3. So 2, 3, or 23 stands for H. E would be 1, 5, or 15. L would be 3, 1. And then L again would be 3, 1, or 31. And O would be 34. Okay, so that's how this works. It's pretty nifty. So you need 2 numbers to represent a letter. Okay, so if we have the message, it is Greek to me, then let's check out the word it. So once again, we find the letter I, and I'm doing column and then row for this. So column would be 4, and the row would be 2. So 42 would be I. T would be 4. We check out 4 and then 4, 44. So it would be 42, 44. Okay, so I'm reading column first and then row. Is ends up being 42, 34. Greek is 2, 2, 2, 4, 5, 1, 5, 1, 5, 2. 2 is 44, 43, and me is 23, 51. So the entire the entire message is going to be 42, 44, 42, 34, 22, 24, 51, 51, 52, 44, 43, and 23, 51. So when attacking a message in a Polybius square, if you think the Polybius square is being used, you can use frequency analysis. It's going to work the same way. So how often are those 2-digit numbers coming up? So this cipher suffers the same fate as the others. It is easy to break. All right, the next one, or the last one that we're going to talk about in ciphering part 2, is the ADFGVX cipher. This one was used in World War I. It was actually used by the German Army for communication from the German High Command to the Army Corps. So this cipher is like a blend between the Caesar cipher, the SPARTAN SKYTALE, and the Polybius square. So it has like kind of a little bit of all 3 in it. It allows the cipher to be stronger than the Caesar cipher or the Polybius square because it overcomes the appearance of the frequency of letters. So frequency analysis won't work on this one as well. So the first step to using this cipher is we have to create a column and rows, just like we did with the Polybius square, except with the Polybius square, we use the values 1, 2, 3, 4, 5. In this one, we're going to use ADFGVX instead. So if you look at the rows and the columns, they have the same values, ADFGVX. The reason why these letters were chosen is because they used Morse code to transmit their encoded message, and ADFGVX is very recognizable and easy to recognize via Morse code. Okay, so what you do with this is you write down those letters, and then you take your alphabet and you take your values 0 through 9 and you randomly place them in boxes. Okay, so that's exactly what happened here. For instance, A is clear over here. 0 is right here, etc. Okay, so step 2, you're going to use that square to encode our message. So let's say our message is Kaiser Wilhelm. So Kaiser Wilhelm, report the row and then the corresponding column. So we're going to look at this and we're going to find the row and then we're going to say the column. So for instance, K, I find K. What is the row it's in? It's in row F. What is the column? It's in column D. So where the two meet, that's where K is. So K is FD. A, I look for the letter A. Once again, I report row then column. It's in the D row and the V column. So DV stands for A, and so on and so forth until we get FD, DV, VG, VD, XD, and then his last name, Wilhelm, becomes VV, GG, VG, DA, DX, XD, DA, GX. All right, so the next step. The next step is to create a keyword and then arrange your message by rows. So let's say we chose our keyword to be the Rhine, or just Rhine, I should say, not the Rhine. That's a 5-letter word. So I write the word Rhine, R-H-I-E-N, and by the way, you can use any keyword you want. It doesn't have to be 5 letters. And what I'm going to do now is I'm just going to put numbers underneath the Rhine keyword. These numbers correspond to the letters in Rhine in alphabetical order. For instance, E is first in the alphabet, so I put a 1 underneath it. Then next would be H in the alphabet, so that gets to number 2. I comes next, that's number 3. N comes next, that's number 4. R comes next, that's number 5. So that's how those numbers are organized. Once again, you look at your keyword, look at each letter, and then label them according to where they come in the alphabet. So which one comes first? It's E. Which one comes last? It's R. So here is our original message. I'm kind of hovering over it. That F, D, D, V, V, G, V, D, X, D, V, V, G, G, V, G, D, A, D, X, X, D, D, A, G, X. Okay, what you do next is you take your message that you encoded using the POLYBIUS square and you write it in rows. So I have color coded this. So if you look at the blue matches up. So FDDVV is this part, and then I can't write anymore, so I go down to the next one, which is in yellow. GVDXD, do you see how they're in rows? Next would be VVGGV. The next row is going to give me GDADX. The next one is going to be XDDAG. And then the last one has an X. Now I filled it in with XXXX because the person on the receiving end would know the keyword. So when they would see this XXXX, they would understand that that just needs to be rearranged. So the next step is to rearrange the columns by the alphabetical order of the keyword. So remember I told you that I was the 3rd letter compared to the other ones? So do you see how I put down here E equals 1, H equals 2, I equals 3, N equals 4, and R equals 5. So what I did was I took those columns and arranged them as such. So the E column got moved over into the first column instead of R. Remember R was there before. And then H column gets moved into the 2nd position. I gets moved into the 3rd position. N gets moved into the 4th position. And R is now in the 5th position. Okay, the next step I did was I took out 1, 2, 3, 4, 5 because we don't need them. And here's what I get. I get this value here. So when enciphering the message completely, I'm going to read the columns this time around, not the rows. So the columns. So if we look out here, it becomes VXGDAX, DVVDDX, DDGADX, VDVXGX, FGVGXX. By the way, you do not include the letters for the Rhine. Remember, it's only these letters here. Okay, so that's what our enciphered message would be, and then I would radio that to the person on the other side, and they would know the keyword and how to rearrange once it's written out the letters, and then they could read it accordingly, and they could figure out what the message is. And that's it for section ciphering part 2. All right, so I'm excited to show you some information about World War II ciphers coming up in the next portion of your course.